friends, welcome to a new video. Today we're going to solve the longest palindromic substring on LeetCode. It's pretty simple. As an input we will have a string, and as an output we need to return the longest palindromic substring. And a palindromic substring is a substring that could be read from both sides. Like here, BAB is the same as BAB, okay? BB is the same if we read it from left to right or right to left, it's going to be the same. Cool. Now, how are we going to solve this kind of problem? As I used to say in my previous video, the first approach should be a brute force approach. So how are we going to solve it with the brute force approach? First of all, let's imagine that we have a helper function that checks if a string is palindromic. Okay, is palindromic string. So this helper function, okay, will take as an input a string and will return a boolean. Just if it's true, that means that this string is palindromic. If it's false, that means that this string is not palindromic. And it's quite simple to create this helper function. You just need 2 pointers, okay? Like for example, 2 pointers here at the start and 1 at the end. And you just need to compare, the pointers and make sure that they are equal, and then increment the start and decrement the end until you arrive to the middle. If at some point you have different letters, different characters, that means that this string is not palindromic. But if you can manage to get to the middle without any problem, that means that your string is palindromic. So we have this helper function. So our brute force approach would be to check all the substrings of my string and then return the longest one. And to do that, we will have 2 pointers, okay? One here called I and another one called G. So both of them would be initialized to the first index. Oops. Okay. 1, 3, and 4. Okay, perfect. And then I'm going to check all my substrings. So at first, my first substring would be A. Is A palindromic? Yes. So I'm going to keep it as the longest palindromic substring. And then I'm going to increment G to the next element. Now my substring is AB. Unfortunately, AB is not a palindrome, so I'm not going to update anything. Okay, and then go again here. ABB is not a palindrome, so I keep going. Here, ABBA, if we use our helper function, we can see that ABBA is a palindrome. So we're going to update now our longest palindromic substring to ABBA. Okay, again, G is going to go to the last one, ABBAD, but unfortunately ABBAD is not palindromic. And then after we reach the end, we're going to reset our G and increment our I. So our I will go to the next element here, and G would be here again. And again, now we have B as our substring, and B is palindromic, but B length is only 1, and our current longest palindromic is 4. So even though it's palindromic, we won't update here, okay? And we continue our journey here. BB is indeed a palindrome, but we're not going to update here because the length is still less than our current longest palindromic string. And again, we're going to update here and go here. And we're going to repeat the process until we reach the end. Okay? So let's talk time and space complexity. So this function is going to loop through all the string, okay? The string in the argument. That means that the time complexity of this function would be O of n. And as you saw here, I had 2 pointer E and G. So I will have 2 nested loops. So the time complexity of this 2 nested loops is O of n squared. but we're using this helper function. So by combining these two, our time complexity of this brute force approach would be O n squared. That's a lot. And for the space complexity, we didn't use any array or any helper data structure. So the space complexity would be O of 1. Cool. So this is the first approach. I will let you translate it to code. Now I'm going to show you the second approach. Just gonna remove this, clean a bit. Clean a bit here, whoops, and clean a bit here. Okay, perfect. Now let's see the second approach. Okay, when I want to approach this problem, I can ask myself some questions. And some of these questions would be, can I reuse some sub-solutions of my sub-problems in order to solve more sub-problems, and then by accumulating all the sub-problems, can I solve my original problem? And the answer is yes. For example, all the single letters, all the single characters can be considered as palindromic. So all the single characters of my string could be used as palindromic. So A is a palindrome, B is a palindrome, B is a palindrome, A is a palindrome, D is a palindrome. And also, we could say something about substrings that are composed of only 2 letters. In this case, this substring of 2 letters can only be a palindrome if both the letters are equal. Okay, so for example, this one is a palindrome, but this one, it's not a palindrome because the characters are not equal. So here we can add B, B. Cool. Interesting. So now, as you can see, we have at the beginning some initial solutions to our some sub problems. Now the question is, can I from this initial solution construct more sub solutions until I get to my final solutions? And the answer is yes. For example, let us take this string. I'm going to call it L1, L2, L3, L4, and L5. And each variable here corresponds to a specific letter. Imagine with me that we know the state of these 3 letters, and we want to know if this substring is either palindromic or not. Okay, so if I know this substring is palindromic or not, the question is, can I know if this substring is palindromic? Okay, so imagine with me L2, L3, L4 is palindromic. What is the condition that needs to be verified for all this string can be a palindrome? And the answer is L1 must be equal to L5. Okay, just gonna write it better. So if L1, L2, and L3 is a palindrome, pal, and L1 equals to L5, we can say that L1 to L5 is palindrome. Okay, so this is the rule. As you can see, we can reuse some previous information, some previous sub-solutions to get more solutions. Okay, and imagine with me that L2, L3, L4 is not palindromic. If L2, L3, L4 is not pal, we can say with confidence that L1 to L5 won't be palindromic. It's not pal. Cool. So the idea here is the beginning, we need to store some initial information, some initial sub-solutions, like these ones, like A, B, 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 A, D, B, B, B are, are palindromic, and use these special equations in order to figure out more and more sub-solutions until we get to the final results. And this approach is called dynamic programming. In other words, DP. And in order to store the information about all of this, we will need a matrix. This matrix will have a size of n. Okay? So in this case, we have 3, 4, 5 columns and 5 lines. Okay? And we will have here indices 1, 2, 3, 4, 1, 2, 3, 4. Perfect. And this is I and this is G. So I will correspond to the beginning of my substring and G the end of my substring that I need to know if it is palindromic or not. So when I is equal to 0 and G is equal to 0, so that means that we are here. So we only have one letter, so we can say that it is palindromic. And we can say the same thing for all the diagonal here, because this substring would be just composed with one letter. So we are confident that they are palindromic. And this diagonal will correspond to substring that are composed only of 2 letters. So in order to know if they are palindromic or not, we just need to compare, the 2 letters. So 0, okay, for this one, 0 and 1, so we are here, so it's AB for this case, and AB is not palindromic because B is different from A, so false. We're going to do the same thing, 2 and 1, 1 and 2, so 1 and 2 BB, it's true, it's palindromic because both the letters are equal. 2 and 3, 2 and 3 BA, false, and AD is false. Okay, and now can we use this equation and this to know the rest of the solutions? And the answer is yes. Okay, so now let's see the substring 0 and 2. So 0 and 2, so let's see this one. Okay, so if I want to know if 0, 2 is a substring, I need to look at this substring, this one. Okay, and this one is 1, 1. Okay, so 1, 1. 1, 1 is true. Okay, cool. So this one is palindromic. And then, as I saw here, I need to compare the sides. So A and B must be equal. Unfortunately, A and B are not equal. So here it is false. Okay? And I'm going here. 1 and 3. I'm going to clean a bit here. 1 and 3. So I'm trying to know if this substring is palindromic. Okay, 1 and 3. I know that the inner substring is palindromic. Okay, that is 2, 2. Okay, 2, 2. So it's true. But B and A are different. So here it's false. I'm going to do the same thing here. 4 and 2. So this substring A is palindromic, but B and D are different. So false. Now let's see 0 and 3. 0 and 3 is all of this. So 0 and 3, I need to check the inner substring. This one, BB, 1, 2. And 1, 2, so the beginning is 1 and 2. It's true, cool. But we need one more condition to verify. We need to verify that the sides are equals. A and A are equal. So that is true. Perfect. Now we go here, 4 and 1. So this one, BA, unfortunately, that is 2, 3. So BA, 2, 3, it's false. So it's false here. The inner substring is not a palindrome, unfortunately. And now our final value, 0, 4, 0, 4, ABBID. Unfortunately, the inner one, BBA, 1, 3, 1, 3 is false. The inner substring is not palindromic, so it doesn't matter if the sides are equal or not. Either way, it's going to be false. Okay, so we've constructed our solution. And now we need to return the longest substring. Basically, we could have you know, in our while we were constructing the solution, we could have kept the longest substring by just, you know, comparing I and G, and do G minus I plus 1. It will give us the length of this substring, and then using this length to keep track of the longest substring. Or we could have just again looked through this array and then check somewhere where it's true and the difference between I and G is the biggest. So the difference between I and G is the biggest, and it's true. So this one, so 3 minus 0 is 3, and so 0, 3, 0, 3. So the answer is going to be A, B, B, A. So we found our longest substring. Perfect. So let's talk time and space complexity. So the time complexity would be O of n squared, because we're constructing our DP array, and yeah, we're constructing our DP array, so n squared, and the space complexity would be O of n squared too. Okay. Well, actually, we just used half of our array, so n squared divided by 2, but still, it's going to go to n squared anyways. Okay, so I think that it's pretty understandable now, and we can move to translate it into code. Okay, so first thing, we will need our results that we need to return. At the beginning, it is initialized to an empty array, an empty string, and then we return our results. And also, we will need our DP matrix. DP new boolean, sorry. And I need the sizes, so I'm going to initialize another variable where I'm gonna put the size of the string and use that variable here to initialize my matrix. Cool. Now we need to put our initial solutions that are trivial into my DP or DP matrix. So for int e inferior to n e plus plus, and dpi I needs to be equal to true because it's trivial. One letter is palindromic. And the second one we need to put the values of the substring that are composed of only 2 letters. So dpi and I plus 1. That's why, because I'm using here I plus 1, I need to go only to n minus 1. Okay, and if we want that substring to be palindromic, we need to check if both letters composing the substring are equal. Perfect. And now the most important part of our algorithm, we need to construct the rest of our DP array. So int I equals to 0 and e. Okay, I'm gonna make a mistake so that I can build the correct answer from it, so you can understand better why I did that. So bear with me. So e inferior to n e plus plus for int g. Okay, as you may see, as you've seen here, g only needs to be greater than I. So because this part we're not gonna calculate it, so we don't need it. Okay, so just g e plus 1, g inferior to n g plus plus. Okay, and yeah, and then dpi and dpg, but we need to be careful to not calculate again these elements. That's why I'm going to do g minus I is superior to 1. So if g minus I is superior to 1, that means that g and I are different from 0. That means that g and I are not equal. So we're not going to calculate again these values. And also g minus I is different from 1. That means that we are not going through this case again, okay? So if dp g minus I is equal to 1, we're going to simply do the things we've done before. We need first of all to check that the inner substring, okay, is a palindrome. And also, we must not forget, we need to check the sides. Char at I is equal to s char at g. Okay. And so this is the new cases, and if we are in the old case, we just put again my values. No problem. Cool. Now, what I need to do is check if the result.length is inferior to g minus I plus 1. That means that we have a new longest palindromic substring that we need to put into our result. So result is going to equal to s substring I and g plus 1. Okay, perfect. So everything seems kind of correct, right? But it's not quite right. I'll tell you why. Just like to be everything and all that. Okay, so if I run the code, short, not short, it's char. Sorry about that. I'm gonna run the code. Okay, we have some errors. I'm going to tell you why. If you recall, when we tried to build our array, our matrix, we didn't calculate like this, like line by line. We calculated it column by column, like this. Not column by column, like but diagonal by diagonal. Okay, and then we reach the end. But by doing this, E is fixed, then we go through G to N. So E is fixed, and we iterate through G. So we're going to calculate the elements like this. We're going to calculate this, and calculate this, and calculate this. But as you've seen, sometimes in order to calculate this one, we need the previous one here. And to calculate this one, we need the previous one here. To calculate this one, we need the previous one here. And by doing that, sometimes we're going to use some values that haven't been initialized, or they have been initialized to false by default. Okay, so that's why we have like somehow wrong answers. Okay, so we need to put the values not this way, not line by line, but by diagonal and diagonal. That's why we're going to make a change here. We're going to swap G and I, and G is going to start from 0, and G inferior to N, and G++, and my G is going to start from 0 to, we're going to stop to G, and increment I. Okay, so now what we're doing is G is going to be fixed, okay? And then I'm going to calculate the elements until G. Okay, so if we are here, we're going to calculate this one. Okay, and if G is here, we're going to calculate this one and this one. And if G is here, we're going to calculate this one, so on. Okay, so now if I run the code, it should work. Okay, I here. Sorry about that. Okay, we've made a mistake somewhere. Okay, let's try to debug. Let's try E++, dp boolean n for int. Okay, so here dpi true, dpi I plus 1 star at I should be equal to star at I plus, and we stop at n minus 1 so that we don't have an overflow here. For int g equals to 0, g inferior to n, g plus plus, and we're going to start I from 0. If they are equal, we're going to just put dpi and g directly because we've already calculated them. And basically we need to I plus 1 and g minus 1, yes, because e is the beginning and g is the end, and check this. And s star at I should be equal to s star at g. That's pretty small. So if the resultant length is inferior to g minus 1 plus 1, we need to replace the results. Not seem to find the issue here. It's like it returns all the time the UDP boolean dpi plus 1 equal, maybe. Nope, should not be equal. No, it's not. It should be superior to 1. What the hell? What the hell? What is wrong with me? So g is fixed, and we're gonna move I. So g is 0, and we move I. I'm gonna just check my... What? I don't have any submissions. God damn. We just figured out where the issue was, and it was here, dpi g. Kind of sad, because, well, we need to check first if dpi g is true. That means we need to check if the substring starting from I and finishing on g is a palindromic. Then we can update our result. And I didn't, I forgot this condition. That's why we always had all the words coming up to the output. Now it's correct. We submit the code, and it's correct. Well, that was a hell of a journey, a hell of an exercise. Hopefully you learned something from it. Thank you for watching, and see you in the next video. Bye!